Okay, good morning all of you. Today we will start one more new topic from physical chemistry. It is the surface chemistry. Surface chemistry. See, it is the completely theory topic and very important for all competitive examination. Very nice concept. Surface chemistry in both point of view is asking 6 marks from this. Out of 6 marks is asking one more question and one farmer's question. Together from this topic we are getting 6 marks. Okay, we will discuss what is the subtopics here, what is the main concept in surface chemistry, everything we will discuss. First of all, we have to discuss what is the meaning of a surface chemistry. Surface, in that only answer is there. The chemistry deals with the surface of the matters. Means is the branch of chemistry which studies the phenomena which are takes place mainly at surface and also interface. Once again you see the concept interface. A branch of chemistry, surface chemistry is a branch of chemistry which studies the phenomena which are taking place mainly at surface of the substance and also at interface of the body. Means what is the concept of this one? We are studying here mainly the phenomena which are taking place at the surface of the body, and also rarely we are discussing about the phenomena which are taking place inside the body. It is nothing but surface chemistry. For understanding, just I will give you one example. Rusting of iron. Generally, according to science, we will call this one as corrosion. It's a corrosion process. Yes or no? Okay, how it is happening? First of all, we have to take the one fresh iron rod. You have to take fresh iron rod. You taken that one. You kept in air. Air means what will be there? Oxygen will be there. Moist will be there. You keep it iron rod for some time, means few days. What happening later? After this, if you keep like this on this iron rod, something we can observe after few days. Yes or no? Yes. What is that one? Some rust will be forming. A brown color layer will be forming on the surface of this iron rod. That phenomena is calling as surface phenomena. This whatever brown color layer will be forming, that is only we are calling as rust. The rust will be forming on only surface or also in inside? No. Inside no. Why? Because the area which is contact with air, in that area only something will be happening. That is only we are calling as a rust. The whole phenomena is calling as a purely surface phenomena. Means like that what things will be going on surface and also interface. This all we are discussing under which topic? Surface chemistry. You see carefully. Next, what subtopics we are discussing here. Under this one, we are discussing about the catalysis. Do you know what is the meaning of catalysis? Catalyst involving chemical reactions. Especially under catalysis, we are discussing about the heterogeneous catalysis. What is the meaning of heterogeneous catalysis? Yes, is a chemical reaction in which reactant will be there, products will be there, catalyst will be there, but they are in more than one physical state. There also this phenomena will be useful, we will discuss. Later we have to see some important things, adsorption, and we have to discuss about the absorption and also desorption, and also we have to discuss some of the important terms, sorption, and very important thing, it is nothing but colloids. The very huge concept and important concept under surface chemistry is the colloids. So just once you see what is the meaning of surface chemistry, is the branch of chemistry which studies the phenomena which are taking place on only mainly at surface and also interface. So just best example for surface phenomena is rusting of iron or corrosion. And you have to see some other surface phenomena is nothing but catalysis, especially heterogeneous catalysis. Otherwise adsorption, absorption, desorption, sorption and colloids. First of all, we will learn about first and main important topic. It is nothing but adsorption. Adsorption. See, concept is enter here. The observe very carefully. Adsorption. Before discussing about the adsorption, first of all, we will see some example. Later, you come to know the concept. See, first example I am telling. I am taking one closed container. In this closed container, I taken so many gas or different gas particles I taken. These all are gas particles. What it will do? It will collide with each other and also collide with the inner walls of the container. That is a KMT, kinetic molecular theory of gases. Okay, anyway, the gas is creating some pressure. That is only we are calling as pressure of the gas. The pressure is, for example, 5 atmosphere in this closed container. Okay, now to this I am adding some coal. I am adding coal means charcoal. I am adding black color coal particle. I am adding. Okay, what changes is coming? Anybody can expect into the same container. I introduced one coal piece. I introduced. Okay, after that, what changes becomes? Yes, you observe very carefully. Pressure of the gas will be decreasing than previous. For example, I observed only 2 atmospheric pressure. Why like that is happening? Okay, whenever you provided coal piece into that vessel, what happening? Some of the gas particles is undergoing sticking on the surface of the coal. After that, what happening? The gas molecule number will be less. Number of molecules is less, creating pressure will be also less. The phenomena is calling as a adsorption. You see some other example I will give you for understanding. You take muddy water. You take. We can see generally in our daily life, muddy water will be there. Muddy water means I taken one vessel. In the vessel, what will be there? Water will be there, and also some muddy particles will be there like this. I want to purify that one. Means I want to separate the mud particle from the water. What we should do? I think you know well-known chemical, spatica, alum. It is calling as potash alum. Yes, it is important for competitive. Potash alum means formula potassium sulfate, aluminum sulfate, hydrated. Hydrated means moist will be. Potash means what? K2SO4. Very good. And alum means aluminum. Aluminum means aluminum sulfate. Al2SO4 taken thrice along with how many water molecule? 24 water molecule. In some competitive examination he asked you this one. Potash alum is a hydrated salt containing how many water molecules in it? 24 H2O molecule. Anyway, it is a transparent crystalline solid, potash alum. Okay, if you add that one, what happening you? It will be separated. Mud particle will be separated from the water. How it is? You can get it. You taken which one? Alum you taken. Yes or no? Spatica you taken. What happening there? Yes, so whatever mud particle will be there, all these mud particles will be sticked on only surface of the alum. Okay, then what will be there? Pure water will be remaining. This phenomena is calling as adsorption phenomena. Can I give some other example for you understanding? You take, for example, in this room, we are feeling lot of humidity. Why we are feeling humidity? The air can't move freely. Why air can't move freely? So moist will be there. Because of moist, what happening? The moist will absorb that a gas particle. That gas particle cannot move freely. But now, what is my target? I want to feel comfortable. I want to feel comfortable here means the air has to flow very freely. When it is possible, the moist particle has to be removed. It is also possible by using one of these special chemical. It is nothing but silica gel. Silica gel. Silica gel means what? It's not any different chemical. Just it is a amorphous form. You studied solid state, amorphous form of sand. Sand means is nothing but SiO2. It's like a gel-like material. Amorphous form of SiO2 is nothing but like a transparent bubbles. Like if you can use that one, what happening? It will absorb the moist. How is that one? I will give you one thing. You take one of the container. You take in that gas will be there, moist will be there. Into that moist, you are introducing which one? Silica gel you are putting. What happening? You know, whatever water droplets or moist will be there, that will be sticked on the surface of the gel. Then what happening? Gas particle will be free. This phenomena is also calling as adsorption. After removal of the moist, the air will be very free. Then it can move very freely. Then you are feeling very comfortable. And you can see one more example. You take raw sugar solution. Raw sugar solution means what? Before getting perfect sugar, before stage. Means in the sugar industry from last to second stage. You have raw sugar solution. Raw sugar solution is basically it is in brown color. Why? Because it is having some muddy particle will be there still. Now I want a pure and white color sugar I want. What I should do? Adsorption I should do. How is this one? You take the same phenomena. You have a sugar solution you have. In that sugar solution what will be there? Sugar plus as well as water is there, and also what will be there? Muddy particles is there. Same phenomena, you can use which one? Charcoal you can use, or you can add little bit charcoal. What happening? What happening on this charcoal? What happening? All muddy particles is undergoing sticking. Then we have pure sugar solution. We have a pure or colorless sugar solution. After the crystallization, we are getting a white color sugar. We are getting. What do you understood here? In all these phenomena, something is happening. Did you observe now? Yes, you observe one thing here. Just I will tell now definition of adsorption. You take for example, coal only you can take. On this coal, in first example, what happening? The gas particles is undergoing sticking. These are which particle? Gas particle. The phenomena only we are calling as adsorption. Anybody can tell? What is the meaning of adsorption? Okay, just you see, in this first case gas particle is sticking, in second case muddy particle sticking on all, and third case which one? Water moist will be sticked on gel, and here again muddy particle sticked on charcoal. Like this anyway, this whole phenomena is calling as adsorption. How is this one means? Adsorption definition: accumulation. Accumulation means in our own words it is nothing but storage of particles on only surface of other substance. Did you got? What is the meaning of adsorption? Adsorption means accumulation or storage of a particle on only surface of other substance. Yes. Here only gas particle is sticking on only surface of the coal. That's the phenomenon is calling as a adsorption. Yes. In these two words is there. Yes. Whatever coal will be there, the coal is calling as words is very careful now. Adsorbent. And whatever gas particles is there, they are calling as adsorbent. In the adsorption we have two words. One is adsorbent, another one is adsorbent. And first of all, you see what is the meaning of adsorbate. Which are calling as adsorbate? The particles which are undergoing sticking on the surface of the other material. That's what you write down. The particles which are sticking or which are sticking on others surface is calling as a adsorbate. Generally adsorbate particles is what? May gas particles or liquid particles. Yes, you take in solid, on the solid the gas particle may be undergoing sticking or liquid particle may undergoing sticking. That's calling as adsorbates. And what is the meaning of adsorbent? Which is adsorbent? Coal is adsorbent. Here Silica gel is the adsorbent. Here again coal is the adsorbent. Means what? The substance which is providing surface for which one? Adsorption. Yes, very simple. Which is undergoing sticking, that is calling as adsorbate. Which is providing surface for adsorption is calling as a adsorbate. But the example for the adsorbent may be like solids or like liquids. They will be calling as adsorbate and adsorbent. Is very clear? Yes. In this case, if you can take moist is the adsorbate, silica gel is the adsorbent. In this muddy particle is the adsorbate and charcoal is the adsorbent. And I will tell you one more thing. It is nothing but desorption. Desorption. What is the meaning of desorption? In the table answer is there. Is the reverse of, yes, very good. It is the reverse of adsorption. Reverse of adsorption means what? Removal of adsorbate. Removal of adsorbate from where? Adsorbent. Very good. It is removal of adsorbate from adsorbent is calling as a desorption. Just I will give you one example. You have already adsorption phenomena. Means it is nothing but alum. Okay, Spatica. Yes, here already fresh water is there, but on the surface of the alum, what will be there? Muddy particles will be there. Yes or no? These are muddy particles. Muddy particles it is. Okay, this is calling as adsorption. Now means what? Desorption. Yes, possible. How? Yes, take a one stick, just stir it. Take it one stick, stir it like this. What happens? Whatever particles is stored again coming into solution. Means what happening? They are leaving adsorbent. Means removal of the adsorbate particles from the adsorbent is calling as desorption. It is possible by chemically or physically. It's not a matter. So what happening finally after stirring? We are getting alum is separate and we are getting water with which one? Muddy particle. This is calling as removal is calling as desorption. All of it clear? Yes. What is the meaning of adsorption? Adsorption means what? Yes, I don't know. Accumulation or storage of a particle on only surface of the other substances is calling as adsorption, which is undergoing sticking, adsorbate, which is providing surface, adsorbate. Desorption means removal of adsorbate particle from the adsorbent is calling as a desorption. Yes, we will see some other example. Now see a mechanism. Now I am explaining some important concept that is very important for all competitive examination. Mechanism of adsorption. How this adsorption will be taking place only at surface? That is a concept also. Understand first of all carefully. I am taking one adsorbate. Adsorbent. Adsorbent means what? We have to take the one body that has to be provide surface for the adsorption phenomena. In this adsorbent, I am taking a particle from interior. From inside, I am assuming one particle. That interior particle has force of attraction in all possible directions. Yes, sir. So yes, you take this. This is the adsorbent. Yes, from inside I am imagining one particle. That particle has force of attraction in all directions. Those force of attractions will be balanced or no? Balanced with which one? Surrounding particle. Yes, why? Because solid means close packing of constant particle. Then from this side one constant particle, from this another constant, from this another, from this another. So interior particle is 100% satisfied with surrounding particle. Is it having any unbalance? No, it is satisfied. Because it is surrounded with all its constant particle. No, now I am taking a particle at surface. What happening? Yes, it is also having some force of attraction in all possible directions or in its surrounding directions. If you take the surface particle, what happening on left side is satisfied with surrounding atom. Right side is also satisfied with surrounding atom, and down is also satisfied with surrounding atom. But what about top? The area which is contact with air, in that side we have what we have? Some unbalanced force of attraction will be there. Unbalanced force of attraction will be there. That unbalanced force of attraction will we are calling as residual force of attraction. Residual force of attraction is what? Yes, the particle which are at surface, they are having some unbalanced force of attraction. That's why always the surface particle is ready to pull something. That's why whatever you are providing, gas particle immediately is sticking on only surface. It's not going inside. Why? It's not necessary. Why? Interior particle is already satisfied. That's why whenever you provide something here, then the phenomena will be taking place only on at the surface. That phenomena only we are calling as adsorption. Very simple amount. Why adsorption will be taking place only at surface means, if you take the particle from inside of the adsorbent, it has force of attraction in its surrounding direction. All the force of attractions will be satisfied by surrounding atom. But if you take the particle at surface, it has some unbalanced force of attraction in which side the area which is contact with air. Then what happening? You are providing something, then it will be strongly pulled with that particle sticking on its surface. Phenomena is calling as adsorption. Are you clear? Yes. Now I am telling some other important thing, thermodynamics. Thermodynamics, JEE mains as well as in NEET examination, we repeated this question. You see carefully. Thermodynamics. Thermodynamics for adsorption. Observe very carefully. Thermodynamics for adsorption. Yes, first of all, I am taking adsorbent. Adsorbent means maybe solid or liquid. I am taking solid only for understanding the concept. And I am taking adsorbate. Adsorbate means gas or liquid. I am taking for my convenience gas particle. I am taking. Yes, you expose gas onto the surface of the solid. What happening? The gas particle will undergo sticking on its surface. Yes or no? Yes, the gas particle will only sticking on its surface. The phenomena is calling as adsorption. Solid on the solid surface. What happening? The gas particle will be undergoing storage or sticking or accumulation. Yes or no? Yes, the phenomena only we are calling as adsorption. Yes. What are the favorable conditions and everything we have to discuss now here. See very carefully. So if like this is happening, in this process anybody can guess whether energy will be releasing or absorbing. I showed one example. You take a gas container. In the gas container you kept some charcoal. Are you doing anything from outside? No. The gas particle itself, it is going sticking on the surface of the charcoal. Why? Then this reactant, this is the product. No, this is the product means it is becoming more stable. More stable means what? After adsorption, the system is becoming more stable. System is becoming more stable means energy will be low or less? High. The final this system will be having lower energy than the reactants. So energy will be losing or gaining up? Energy will be losing. Then the reactant finally after adsorption, the system will having more stability means low energy means energy will be releasing. So energy will be releasing means, yes tell me, energy releasing process is calling as exothermic. Very good. Exothermic phenomena. Exothermic phenomena means enthalpy change for adsorption. Sign is what? Yes, very good. It is nothing but negative sign. My question, according to this concept, the phenomena will be favorable at high temperature or low temperature? Yes, very good. Why? Because energy will be releasing. No, the process is not requires energy. The process is not requires energy means the process is taking place at low temperature. Yes, that's why adsorption will be favorable generally at which temperature? Low temperature. Yes, I will tell you a simple example. You taken some gas you taken and you are maintaining room temperature. The gas particle will be sticking on this one at 25 degrees. Now you taken one stove or Bunsen burner and you are keep on heating. What happened? Desorption is happening. Why desorption is happening? Why supplying energy, the gas particle raises its kinetic energy. Then they are coming outside from the solid body. It's called as desorption. So adsorption will be favorable at low temperature. Very nice point. Later we have to discuss about one more thermodynamic term. It is nothing but entropy. Yes, at thermodynamic class we discussed this point amount. Anybody? How can you show entropy? Yes. What is the simple word regarding entropy? Disorderness, randomness, or nothing but disorderness of particles in system. Whatever you are taking in that system, randomness or disorderness of a particle is calling as entropy. I told already, yes, you have solids, liquids and gas. Just for example, where entropy will be more? Gas. Very good. Why? Because in case of solid phase, the constant particles are very tightly packed together. That's why the randomness will be almost zero. That's why entropy will be zero. If you take liquid, little bit free, yes or no? Yes, because force of attraction will be less. That's why entropy will be not equals to zero. But you take a gas molecules are very far away from each other. They are moves randomly. Means disorderness will be very high. That's why entropy of gas matter will be very high than liquid than solid. Okay, now you have to apply this concept to this adsorption phenomena. What is the entropy change for adsorption or any reaction? Entropy change means what am I? Entropy of the products minus entropy of the reactants. Observe very carefully. You come to this point, entropy of the solid matter, is it zero? Gas molecule entropy will be very high. After adsorption, what happening? Products will be formed. In products, what is the entropy change? Means entropy value. Is it zero? Or is it very high? No. Why? This gas molecule will be sticked, but they won't sit calm. They continuously exchanging their positions. That's why here also entropy will be there, but not equals to zero, but low value than pure gas. In the pure gas, randomness will be very high. After sticking, its randomness will be little bit less. That's why after adsorption, entropy will be low. But before adsorption, gas is having highest entropy, but solid entropy will be almost zero. Now, I am telling entropy change for this system. Entropy of the product, lower value, yes or no? Minus, solid leave it. Reactant will be higher value. Then what we are getting? Lower value minus higher value means very good amount. You are getting negative value. So entropy change for adsorption. Entropy change for adsorption, we are getting negative value. Means we are getting entropy change for adsorption will be also negative value. Now we have to see one of the Gibbs free energy equation. Did you know? G is equals to very good amount H minus Ts. Change right out. Delta G is equals to delta H minus T delta S. Okay, again we have to work out something here. Delta G. Based on delta G sign, we can tell whether it is spontaneous or non-spontaneous. If delta G value is getting negative value, very good. It is nothing but spontaneous. If delta G is coming positive value, means non-spontaneous. Are you getting or no? Spontaneous means itself going, but non-spontaneous means we should do something from outside, then only it is proceeding, calling as non-spontaneous. Okay, now take this one, delta G is equals to delta H minus T delta S. Okay, delta H value what amount? Negative value, minus of temperature into delta S will be also negative value. We are getting negative value, minus of minus plus temperature. So now I want the process will be spontaneous. Delta G should be negative value. The whole value will be negative value. Then the process will be spontaneous. The whole thing is integrated with which one? Temperature. You take a temperature is very low. Then what happening? Negative value is coming. No, you are taking this is 100 minus 100. This is plus 400 becoming positive value. So the whole process is depending upon temperature. So when it is becoming spontaneous, The temperature should be very low. That only already I told here. Adsorption phenomena will be favorable at low temperature. The very